the world would be nice if everything you needed was already written for you, but frankly, we'd be wasting our time talking about all this stuff because you wouldn't need to, because you probably wouldn't need to do programming. But the fact is that once you start programming, you open Pandora's box, and you're going to need to write your own routines. So let's talk about how we're going to do that. So we'll talk about defining a function. Once we start defining functions, we get into this domain where we have global and local variables, so we'll talk about what that means. How one deals with function naming, the fact that the name is really just a pointer. We're going to talk about how you define the parameters that go into a function, how things get passed, and the return statement. Okay, so you define a function very simply. You say define, followed by the name that you're going to assign to the function. The parameters, we'll talk about what that is. A colon, parameters need to be in parentheses. And then you have a bunch of lines. You may or may not end with a return statement. You may have return statements in the middle too. And you indicate that you're done defining the function by ending the indent. So it's just a block of statements. Of course, if you have an if statement, it's going to be further indented. So everything that's the way that if this is in the first column, then the way that I know that my function I've completed the function definition is because I have some other statement that begins in the first column again. Once you've done this, immediately afterwards I can call it. So I've defined this function name and I can pass it parameters and get the value back. So it becomes just like any other built-in function in Python. Let's use a simple example. Well, I made sure I did the homework first. Here's a factorial function. Okay, I define factorial. It gets passed one argument, n, and I do exactly what I did before. Start by setting the product to be 1, and I loop over the range from 2 to n plus 1, meaning 2 to n, values 2 to n, and I get back the value, and then I return it. So the function, all the lines in the function are indented to the same level, and the indentation, if I put another line after this, it wouldn't be part of the function as long as it was indented. If I put in another line, by the way, that was matched the return indent, so let's say right here I had a line that said print prod, that would be valid. I just would never execute that line because I always do the return first. So I would never get to that line, but it's valid. Okay, so once I've done that, just like all the other functions, we can just say factorial, pass in an argument, and it'll do factorial for us. So it's very simple to add your own stuff. Now we can do a little bit more work here. Now, if you remember, in my factorial process here, I'm defining prod. That's the first thing I do. What about if I define prod ahead of time and I call factorial and then look at prod? I didn't change it. Why? Because the prod that I define inside factorial is local to that routine. Okay? It's going to create a new version of that variable for me and use it, and that will be a separate one from the one that I've defined outside the routine. And if I were to delete this before I use it, so I delete it, call factorial, there's no variable. The variables that are created inside my function are deleted when the function exits, or at least certainly are not available. Unfortunately, to make matters a little bit more complicated, there are times that we want to get stuff into our function, and for one reason or another, we don't want to pass them as arguments. It's not a healthy way to do things, but we can do that all the time. Here I'm defining my factorial function, but I'm not putting n as an argument. If I'd run this version of factorial, then if I don't define n, I get an error because it runs up to this point, and then it gives me an error because it doesn't have a value for n. But if I then define n and call factorial, it does work. And what's going on here is that this is a local variable because I've defined it here. For n, I haven't defined it before I used it. So Python says if you're using a variable and you haven't defined it, then you must want something that's global. You must want something that's defined outside of the function. So therefore, it's going to look for an n that was defined outside. Okay? But if I had defined n equals 5 before I used it, it would say, okay, that's a local variable. That's a variable that's local. And you can see here that it recognizes that n must be global since it's not defined before I use it. All right. So this is what's sometimes called automatic global variables. Python will automatically look for a global variable even though it's inside a function. Yes, John? Well, as we'll see when we start writing modules, it's a global variable is at most global only to the module, and unless you import it by with import star, and it is and since we can nest function definitions inside of functions, it will only be at the level global at the level where the function's defined. So if I have a function that contains this factorial, I believe it'll keep looking levels, each level out until it satisfies it. In general, this is not a good thing to use. But you should recognize that it will be used even though you didn't necessarily intend it. Okay, so what about if I want to export this variable prod so that it is accessible after the routine's been run? I can do that by calling it global. So here is my factorial routine, but I have defined prod as being global before I used it. So now when I call my factorial routine, it overwrites the value of prod that's been defined outside. So the global statement is there if we want to use it to make something be global. Yes? This is the same prod. This is the same prod. So what this is doing is this is saying that prod is going to be, when it does this, I'm saying that the value, that prod points to the variable at the at the outer level. So even though I'm defining a value for it, I'm pointing to the same variable that's outside. It will create it. So if I deleted prod and then ran this, prod would exist. It doesn't have any problem with it. Global doesn't require that the variable be defined ahead of time. It will allow you to define it. But it's saying that when you define it, do it at the global level. Now, what I'm not clear about is what would happen, I should play with this, but if we had this code and we defined a variable that we didn't access, I don't think it would actually define it. Actually, let's try it. So, so let's say def capital X sub n, just to give it a parameter, global new var. Oops, I better not do that. Return 1. Okay, so X doesn't do anything terribly exciting, but if I do print new var, obviously I get an error because it doesn't exist, and then we'll call X on 11, let's say, and returns 1, and new var still doesn't exist. So it doesn't actually, global doesn't create the variable. It just simply hooks it up so that if I do create it, it'll be there. It'll be created at the global level. If I had put new var equals 1, then I would create that variable. What's that? Inside my function. Right, exactly. Yes? Mm-hmm. It would only be, the global statement only matters inside the routine here. So if I have x1 and x1 uses new var, but it doesn't have a global statement, it depends. If it uses new var and defines it on its first use, then it will be local. If it accesses new var, assuming that it already has a value, then it's going to look for it at the global level. Okay. I don't know whether I would have designed Python to do this myself this way. It's probably one of those things that computer scientists would say, nah, this was a really bad idea. I will say from a perspective of a scientist who wants to write code that works and doesn't care whether it reaches the highest standards of computer science, it's very convenient because it works the way I want it to. Okay. And there are times where, you know, I've got all this complicated stuff. It turns out it's going to be very useful when we get into writing classes. But until we do that, it'll make a little less sense. But it's very convenient to do things this way. Okay, so let's see. So let's talk a little bit more about the different parts of a function. So when we do define with a function name, so here's what we define. The function name has the same rules as variable names. They can be as long as you want, or maybe a better way to say it, as long as you're willing to type. And they actually are variables. So when I define my factorial function, if I just simply ask what factorial is, it comes back and tells me it's a function, and here's where it's found. And if I say fact equals factorial, well, now I've defined a different pointer to the same thing, and I can use that. So this may not be the most useful example, but it's not that uncommon for me to define some list or dictionary or something like that that contains pointers to functions. So I might define a piece of data and then define the function that I'm going to use to do something with that data. Yeah, Jan. Yes. Right. Exactly. Exactly. Right. So, well, you get it is a common place where people get confused. They call a function, and it didn't do what they thought it was going to do because they didn't include the parentheses. So I'm trying to think of an example of a function that you call without an argument routinely. Yes, now is an example. Yeah. If you call it without brackets, then you're then you're going to get then rather than getting the value for the time and date, which you're expecting, you're going to get a function, and your code is going to bomb when you try to format that function when you meant to format a string. Yeah. Yeah. And it won't show up as a syntax error because it's perfectly valid syntax. It's just not what you wanted to do. Yeah, this is one of those cases where there is a lot of power in being able to do this, but the downside is that if you really wanted to make factorial, factorial 5, you didn't succeed. Okay, so we've talked about function names. Next thing we'll talk about is parameters. And it turns out that parameters are even more complicated than what I'm going to talk about here. But the simplest case here is here's a function that defines that requires 3 parameters. Parameter 1, parameter 2, parameter 3. And it's going to return something p1 plus 10 times p2 plus 100 times p3. So function 1, 2, if I call that function on 1, 2, 3, then I get 321. No big deal. If when I call this function, I don't have to specify the parameters just this way. I can specify them by keyword, and I can say p3 is 1, p1 is 2, p2 is 3. And it will sort that out for me and say, okay, you wanted this 1 to go to the 3rd value, and it'll put it there and so on. So now I get, instead of 3, 2, 1, I get 1, 3, 2 because I've specified those. That's how the parameters are supposed to get sorted out. I can even mix the two. Here I put a 1, so that 1 doesn't have a name. It must be P1, and then I specify P3. If I don't specify the right number of parameters, then I get an error because it's looking to get 3 values. And if I don't specify enough parameters, then again I get an error. So you can run a function with parameters specified 2 different ways. By specifying the parameters in a default order, or you can specify the parameters by keyword. Okay. Here I've done the same thing as I did before, but you'll notice I've got an equal sign there. So here I've got P2 equals 2, P3 equals 3. What that means is those are default values for these parameters. So if I call this function and I specify the parameters just as I did before, it runs exactly as it did before. But now I can run the function and only specify 1 parameter. And then P2 will default to this, P3 will default to that, which is why I get 21. Optionally, I can specify a value for P3 without specifying P2 because, again, it has a default. What would happen, by the way, if I specified 0 parameters? Any ideas? Error, exactly. It requires a value for P1. If I don't have a value for P1, it says this requires at least 1 parameter. It's not going to work with none. But I could make it make P1 optional as well if I wanted to. Yeah. Mm-hmm. No, you can't do that. I think what would happen is I define factorial 2 different ways. I think I probably confused you by using the same name twice, but you can't do that. If you define a function and it requires a parameter, it requires a parameter. This function will give me an error if I use it with 0 parameters, and it will also give me an error if I use more than 3 parameters because it won't know what to do with them. Yes. Mm-hmm. Right. Okay. If you're saying if I define a variable in an if statement, but the clause isn't run. So if I say, for example, if false, a equals 1. And then, so that a will never get actually defined, but it's referenced in a sense. The first time I try to use a, if I look for its value and I'm inside a function, it's going to look for it at the levels outside. It's going to look for it as a global variable. And if it doesn't find it, it's going to give me an error. Yep. It's not going to it's not going to define the variable because it never ran any code that did it. So in a sense, Python never really looks at the code that you don't run. I mean, it's exactly the same as if it were commented out. It doesn't do anything with that code. So the variables, the only variables will be there are the ones that are defined. Okay. Originally, when I wrote this, I put in a couple more slides on how to do much more sophisticated parameter passing. And then I was looking at it and saying, you know, that's just too much stuff. So I took it out. We'll talk about that hopefully next month. But you can define parameters in more sophisticated ways. You can pass parameters in more sophisticated ways. And we'll want to see that before we get into GUI programming because it's used there. But for this point, you know, I think you've seen sort of enough. You've seen how to define optional parameters. You've seen how to use parameters as keywords versus using as positional arguments. But what you should know is that there's a lot more stuff out there, so you can do things in more sophisticated ways. Yeah. Mm-hmm. Sure. Yeah, absolutely, absolutely. If you that's the reason why variables contain pointers to functions. So, you know, I could I don't want to write this on the top of my head, but I could write a function and give it a reference to math.sine or math.cosine, and define that as function. And then I just simply call function, and it's going to run whatever I've pointed it to. So absolutely, you can definitely pass functions as, you know, when you supply a function and you don't supply parentheses, it's just a pointer to a function, and you can pass that just as easily as you can pass anything else. Yes, Art. Mm-hmm. Yep. Yep. Or a tuple. Yep. You can only. I'm gonna come back to. I think I. Yep. That's that slide. So I'll come back to that. But the answer is, if you want to pass, you return more than one thing, you've got to make it into a data type that contains it. But let's talk about modifying parameters first. So here I define a function, and it's a one-line function. I define a function, and then I give it a value. Give the argument a value. So what happens is that let's see. Actually, I should have done this. Yeah, well, here's a good example. I'm taking B, I'm defining it as 10. I call this function, and this function takes the argument and sets it to 1, okay? But it doesn't change B. Okay? What's going on here? Well, it's defining a local variable A. It's making A a pointer to whatever I pass in, but now I'm replacing that pointer to a reference to my constant 1. So it doesn't change B because B is still a pointer to my original value of 10. Likewise, even though this function here is getting a constant, it's taken my constant, it's defined a local variable A. The fact that I've overwritten my local variable A doesn't create an error because it's not trying to overwrite my constant 9. It's just creating a new pointer and it's overwriting that pointer. However, if I pass a higher level data type, then that isn't what's going to happen. So here I'm going to change the first element in A to be 1. So here I define B to be a list. I call my function, and then I look, and it's changed B. It's changed the first element in B. What's going on here? Well, if you think about this, it's taken B, I've passed it here. A now references the same piece of data that B does. Here I am changing it in place, and sure enough, it's changed outside. Okay, so this is another example of where those those pointers, that referencing, does something different because of the way that Python works. This can be really useful, but it can also be damaging when you don't expect it. And when we pass a tuple in to C to the function, we get an error because we're asking it to modify the tuple, and tuples can't be modified. That's why we have them. Okay, so yes. Correct. Yep, it would either overwrite or add the key. That's exactly right. The question was, what happens if I call this thing with a dictionary? And the answer is that it will either create or overwrite the element, the element with key equals 0. Okay. All right, let's get back to Art's question. What do you do with return? Return only takes a value. What is that value? Well, it can be any kind of data type. Python's very happy to pass any data type you want, but it can only pass one thing. Now you'll see a lot of times people are doing things like this. Return a bunch of values. And you might think, okay, Python's very happy to return a bunch of values for us. But that's not really true. What it's doing is it's making a tuple for us, and it's returning that tuple. So you're always really returning just one value. If you don't put a return statement in, or you just put return followed by nothing, then you're effectively returning the value none. So if I have a function that just ends without a return, and then I call it and say x equals my function, parentheses, whatever, and then I look at what x is going to be none. Okay, Art, does this answer your question? Okay. And I don't know if do I have an example? Let me just show you one quick idea of how that works. And it's a little strange at first, but we can say, I'm going to define, I'll redefine my x here. And I'm going to define it as return 1, 2, n. And that's defined. Now what you might see is that people do a, b, c equals x sub 5. Okay. Well, and you look at it and you see a, b, and c are exactly what I think they should be. So this sort of looks like Python is allowing me to return 3 values here, and n could be complex. I could do this again with a list, which works better when you can type. Now C is my list. So you might say, well, gee, this is doing a very nice, this is returning 3 values. But what it's really doing is it's just simply creating a tuple. It returns a tuple. And I'm taking advantage of the fact that you can automatically assign a tuple. You can break up a tuple by assigning a tuple to a tuple of variables. So very commonly used syntax. You could probably ignore the fact that Python is doing the way that Python's handling it for you. But what you should keep in mind is that I could also do this way. So D is that, and D, and the type of D is tuple. Okay. So return. in practice, you don't have to know that. It's just, it works the way you'd want it to work. Yeah. Sure. An array is an object, and you can return an array. So we'll talk about how you set up Python, how you would set up real arrays next week when we handle NumPy. But you can pass, you can return anything. So you could return the name of a function. You can return the name of a list containing 10,000 values, and you're just passing a pointer to that list. So you can return anything you want. And if you want to, you can return several arrays by creating a tuple or list or whatever you want, dictionary of lists, dictionary of arrays. Am I clear? Okay. So you can pass anything, and by the way, when you pass something, you're just passing a pointer. So it's really fast. It's not making any copies of anything. It's just giving you a way to access what you wanted. Okay, so I've gotten you to the point where you can create real havoc for yourself or for other people, so I should comment a little bit on style. First thing is that write simple functions. Don't sit down to write a function that's going to solve your need at the beamline to do 20 different things. Write 20 different simple functions. Okay? While you're writing the function, document what you're doing. The best functions are the ones that have everything as arguments and give you back something when they're done. And then you can tell people, most notably yourself, for the next time you look at it, this is what my function does, and this is what I'm going to get back from it. When you write a function, how do you know if you've written the right thing? Well, the best way is to create some test data so that you know that the function does everything you want. Now, I don't know how many people remember when Intel put out a buggy chip that didn't do floating point correctly everywhere. For floating point, I think it was multiplication. Did not work properly for some numbers. Well, they learned very quickly the value of testing, not just that it multiplies numbers correctly, but that it multiplies all numbers correctly. So when you write your function, if it's working on numbers, you want to think about what is it going to do on any possible input it's going to get. We'll talk later about the idea of unit tests. The best way to code, in my opinion, is where you write a function and you provide, as part of that function, test code to make sure that it works properly for a large range of input. So when I took Bob Bondriel's Python space group code, the first thing I did was I wrote test routines to make sure that it worked on all 230 space groups. And while I was at it, I can't test every possible non-standard setting, but I picked out some non-standard settings as well. And actually what I did was I generated input using a completely different package so that I could check that his input, that his calculations agreed with what some independent source did. So that now I have some confidence that Bob's space group code is going to work properly wherever I use it. For that matter, I've set it up with these unit tests so that whenever I bring it to any new platform, I can check that it works the same as it did on previous platforms. And I don't typically do this, but I'm thinking specifically of one person, probably the most impressive programmer who I ever watched, and I won't name him since this goes out to YouTube at some point, sat down, and the first thing he did is said, I want to have this particular math library function. So the first thing I'm going to do is I'm going to go figure out where am I going to get values to test it. So he accumulated the test data that he wanted. He wrote the comments for how the function should work, and then he wrote the function. And then the last thing he did was test to make sure it did what he thinks it should. All right, so here's a little bit of homework, and where time has really flown by. Write a function that takes a variable number of arguments and returns the product of the function. Write a function that takes a variable number of arguments, returns a tuple, and I give you some hints on that. And that's it for this homework, for this teaser, I guess. It'll give you a little bit to think about in terms of what you've seen in terms of the lecture.